been great to be here this year because I'm also part of the community as you are and see a lot of projects over there and happy to engage all the things. So I'll present you Alessandro and Adrian from the cloud base that will show us the Flatcar Container Linux. The floor is yours.
Thank you so much. Well, thank you for your trust. Usually the applause comes at the end, but we appreciate that. Okay, so okay, we're going to talk about Flatcar, hopefully. All right. About us, so my colleague Adi will be the main speaker today.
Hello, my name is Adrian. I'm a cloud engineer at Cloudbase. I'm also a Flatcar Container Linux maintainer. We'll be glad to share a lot of about Flatcar today. Thank you for coming.
And my name is Alessandro Pilotti. I'm the CEO at Cloudbase, and I will also show you a few things related to Flatcar today. Okay, a quick outline about what we're going to talk about today. Well, there will be introduction about what is Flatcar and so on. How many of you guys know about Flatcar already? Okay, some hands, good, right. So we will present about it, talk about what it is not, how it works and everything, what's different, let's say, about Flatcar compared to other Linux distros and so on. Then we will have a demo, right? Then we will talk briefly about two types of workloads that we are running on top of Flatcar. One is the biggest type, AI type of workloads, right? And one is the smallest type, like serverless type of stuff, right? So one will be basically NVIDIA drivers, and the other one will be basically Hyperlight, as we'll get there soon. So Flatcar is a very compact and easy to run Linux, right? So the whole idea is like to make an operating system which is meant as a host operating system, as opposed to, let's say, a container type of image, right? That will provide everything you need to run host-related type of workloads and start containerized or other type of workloads on top of it, right? It's image-based, meaning you take an image, you just deploy it on your system, and off you go. And it's secure and reliable by design. That's very important, right? Because the main idea is to reduce as much as possible the attack surface when it comes to the type of host operating system you want to deploy. It's tailored for containerization and, of course, for Kubernetes and, in general, cloud-native type of workloads. Now, we have two slides here. You might say, well, I cannot see anything. And that's exactly the point. There are so many projects today in the CNCF. And out of them, only one is an actual Linux operating system, right? Which is quite interesting, considering we're talking about the Linux Foundation afterwards, right? So, not to spend half an hour now playing Where's Waldo, right? You can find on top Flatcar, right? So Flatcar is basically the only Linux which is there. So the interesting thing about Flatcar is the fact that it got accepted by the CNCF for incubation, right? And it's now going for graduation. You might wonder, why is it taking so much time? The funny thing about that is that you know, the CNCF is made for open source projects related to, you know, containers typically, or their related type of containerized and so on workloads, right? Getting a whole operating system, right, as part of the CNCF, it's a whole completely different type of task, because there are so many independent components, lots of licenses to deal with, and so on. So it's a nightmare for lawyers, basically, which is relatively funny, in my opinion, because, again, we're talking about the Linux Foundation, so the fact that we want to have a Linux as part of the Linux Foundation takes more time than just a regular project, right? As I mentioned, it's the only project in the CNCF matrix at the moment. And, well, there is also a link where you can find it. Okay, now I pass it to my colleague Adi.
Thank you, thank you.
Thank you.
Thank you very much. So let's understand a little bit on the Flatcar. What's all about Flatcar? And I have started with let's say a little bit of down to upwards Let's talk about the ancestry. So Flatcar, when CoreOS, the container OS was, let's say, dropped from the development cycle, Flatcar appeared as a drop-in replacement, so one-to-one replacement for CoreOS. It's an operating system made from source packages. It's a downstream fork of Gentoo. There was a great talk before from Aleodor, who here has run, who runs Arch Linux. Anyone here running Arch Linux? Built Arch Linux and run it. Who here has built Gentoo and runs it? Built only, right? Okay, so actually building Gentoo, it's quite an endeavor. I did it myself, and it took me half a day to understand how and why. Gentoo is a project made in the 2000, and it took them 25 years to actually provide images, like usable images, not do seeds for building your image. So actually or the beginning of this year, Gentoo created the images. So important to note, downstream fork of Gentoo, what comes first in Gentoo, then it's consumed by Flatcar after some time of testing. Flatcar pedigree. It's an immutable OS. Being immutable, it means it is consumed as an image because there's no other way, of course, logically to consume it. It's similar, but not the same to Fedora CoreOS. So Fedora CoreOS and Flatcar are some sort of siblings. They share a lot in common. Then it's OpenSUSE Leap Micro. They share the same bootstrapping, the ignition provisioner. We'll talk later. There is also the Particle OS. Anyone here heard about Particle OS? It's the new systemd child. Basically, very similar in purpose to Flatcar, but it started from a project like, so you start with canonical Ubuntu or a Fedora, and then you make it very systemd-like. And there are the other two OSs, which are quite different in the sense that they're not generic or semi-generic like Flatcar. They're tailored only for Kubernetes. I'm talking here about Talos, who has a very different approach of doing things. It has only an API, or Kairos, which is also for Kubernetes, but it's very similar to Particle OS because it starts with a seed from Ubuntu or Fedora, and then puts Kubernetes on top and continues. Let's talk about the Flatcar images. So a very small image footprint, around 500 megabytes. It's the image. Around 300 source packages, most of them 90% inherited from Gentoo, just a few tweaks, mostly to the kernel and the initrd and systemd. How does it, so if you get a QCOW2 and then you compress it, a Flatcar image, you'll have the same image size. So how do we get there? The USR partition, the one that holds all the binaries, it's compressed using the Btrfs compression. So it's a file system level compression. The boot partition uses native compression, as in initrd and group binaries are already compressed. So it comes with the minimal amount of megabytes downloadable from where you consume it. Supported architectures, we support AMD64, ARM64 out of the box. I have just presented this year at FOSDEM a POC, work in progress right now, on RISC-V, so it was quite easy, or rather easy, to add support for another architecture, the upcoming open source architecture. You'll probably all gonna hear about soon. Flatcar images, when you consume a Flatcar image, because it comes in a read-only fashion, an immutable fashion, you need to have images, different images, for the OEMs, for the cloud providers. So what does that mean? We'll talk a little bit later, but it's a set of files, additional files, specifically for Azure, for example, or for QEMU or Hyper-V VMware. For example, for Azure, you need the so-called Linux agents installed so that it works on Azure. Built-in security, it has an immutable USR partition. Note, not the root partition is immutable, but the USR partition. It uses A/B partitioning scheme for updates, very similar to SteamOS, for example, and a few varieties of or Arch or other. But important to note here is that when you want to change Flatcar, you have to build it from scratch. And you have to use another Flatcar image. So you cannot do an apt-get install, you cannot do an RPM install, you need to build the image from scratch. And I will show you later, you can also extend it via, again, a read-only and immutable systemd sysext. Security-wise, DM-verity against attacks to the USR partition. USR partition is immutable, but you can still change it bitwise if you unplug it and do DD on it. So DM-verity protects against that. Secure boot, supported. LUX2. Flatcar is highly integrated with systemd, so it supports LUX2 encryption, TPM, HSM via the systemd toolchain. And there's also Clevis and Tang, which are very similar to what systemd does, but in terms of host it yourself server for the keys for the LUX2 encryption. How do we do updates and releases? Every month, alpha, beta, stable, rolling releases. There's an LTS. It has a yearly cadence, is released once a year, and is supported for 18 months. And it's updated minor releases every month, along with the alpha, beta, and stable. To control updates, there is a way, there's a Flatcar project called Nebraska. Someone here familiar with landscape foreman to control updates, groups, the life cycle? Anyone here use the landscape foreman? So the idea is you can control the Flatcar fleet updates using green, red, or black-green approach. You can upgrade only part of your fleet. Let's go to bootstrapping. This is important. The difference between the main difference in terms of usage of user from the Flatcar perspective is ignition. Ignition is a very similar feature set to Cloud Init, and it does the same thing in different domain language. Capabilities like storage, systemd, units, networking, users. The focus here is that it does it during the initRD very early boot stage versus the Cloud Init, which does most of the work after the system has booted, fully booted. There's also a replacement for Cloud Init. It's called CoreOS metadata, because people try to deploy Flatcar on OpenStack and realized, okay, but ignition doesn't work. So there's also CoreOS metadata, which is very similar it's actually feature parity with Cloud Init, but less used. Oops, I did press. Okay, let's go to the purpose of Flatcar. You have to, Flatcar Container Linux, the only purpose for it is to run containers. But how do you do that? By default, Flatcar just consumes the Gen 2 packages, and there is no Docker or containerd, because you want to be flexible on what type of container runtime to put, what type of container management to put. For example, you can have Docker or Podman or Rancy, Cryo, and all the stuff. So here comes the systemd sysext. Systemd sysext is a feature of systemd. When Flatcar is immutable, the only way to extend it is via an overlay file system, which in itself is immutable as well. So basically this way, the systemd sysext being a squashfs overlay system, you can put read-only files on top of the file system. So the OS thinks that you have the same, let's say, the merge file system. So this way you can have Docker and containerd. Let's go with a basic QEMU demo. Let me know if you can see my screen here. I'll show you how to boot a Flatcar. So this start the demo here. Oops. Demo base. What it will do, it will download the ARM64 image, the FE variables, everything related to booting a QEMU Flatcar. You saw there very fast. There were two partitions, A and B, and now it boots. I would like to show you very shortly. It's booting. Okay, great. So by default, it comes with Docker and Containerd. Flatcar comes with Docker and Containerd. Let's run a hello world. Everything working. And what I wanted to show you here is the CSX list. So you can see here, it has three CSX, three extensions for Flatcar: Containerd, Docker, and OM QEMU. As I said, the OM QEMU basically just overrides some kernel parameters so that Ignition, the bootstrapper, knows it is on QEMU and where to take the metadata from. Because QEMU metadata is sent from the firmware. Okay. We are short on time. Let's go to the next demo. Okay. For composability, Flatcar has a lot of CSX in the so-called CSX bakery. You have other container runtimes, also container managers like Podman that is already built in. You have Kubernetes, the vanilla ones, K3S, RKE, Falco, Tailscale, and also NVIDIA drivers my colleague will show you very soon. So should I go to the demo related to NVIDIA? Yeah. Okay. So we are at Cloud Native Days. I'll show you how to run a K3S on Flatcar. It's a little bit more involved. So what I'm going to show here, it's quite, so Flatcar will boot, and it will download at boot time. Ignition will download the K3S extension. And then via a systemd unit I set in the Flatcar Ignition configuration file, let's call it user data, similar to Cloud Init user data, it installs and configures K3S. So as you can see here right now, it's downloading the extension, and soon enough I should have a running Kubernetes on Flatcar in like 2 minutes. By the way, I'm running this on ARM, so you can see it here, and you can see CSX list. Oops, come on. You can see the difference. I have another extension here, K3S raw, which is the squashfs raw squashfs file system. And in some time, yeah, a lot of messages should appear. So I should see the containers creating the K3S ones. Okay. K3S, scripts. And I also downloaded K9S. I'm a fan of K9S. You can see it here. You can see all the pods running nicely. Everything is going perfect. This was all from my demo.
Thank you, Adi. That's perfect. All right. Okay, I will talk briefly about, you know, having the operating system is great, but what matters is mostly what you run on top of it, right? So I'm talking about two types of workloads we typically use Flatcar for. One are AI type of workloads. So we do a lot of AI these days, meaning that we need a platform capable of running GPU, right? Drivers and so on. NVIDIA, of course, is the main platform these days. NVIDIA is a bit problematic to integrate in Linux. Famously, Linus Torvalds had some words about it, right? Since this demo is being recorded, I put some omissions in the final part. You're probably familiar with what he said about it. And yes, it is problematic to deal with it, because each card typically works with a given set of drivers, so driver version, CUDA version, and so on. Mixing and matching can be problematic very often. So if you're used to a traditional Linux distribution, you will have, you know, to apt install or yum install the specific drivers and everything. The beautiful thing about Flatcar is that you do that with a simple configuration file using butane, which in terms means ignition, as my colleague Adi already mentioned. And you will define in a configuration file which version of the driver you want, as you can see in the snippet at the bottom of the screen, right? A little bit of YAML. Who doesn't love YAML these days, right? And that's one thing. So you want a different version of the driver, you just specify there, and off you go. Another thing is that, and that's of course for the operating system itself, right? So at that point, the operating system will see your card, and you will be able to run your NVIDIA workloads. But since we are talking about Docker in this particular case, you also need to have the NVIDIA runtime for Docker, right? And that's another easy extension to add. So as you can see in the snippet, I added also a file, right, which is the extension that simply gets downloaded, placed in the right place, and whenever you start your operating system, you have it in place. So I will switch now to a demo, very briefly.
So
this one, right?
yes.
Okay. Okay. So I have to do everything single-handed here.
I can help.
No, I'm good. Up. Okay. So this is a QEMU VM. Sorry, switched back to black. So QEMU VM, and I configured on that particular machine. There is an NVIDIA card, right, an RTX card, which is configured for going in pass-through, PCI pass-through to the VM itself. So if I do an NVIDIA SMS, you can see that the card is visible. I didn't have to do anything else except passing that configuration file when I started the machine. Everything else was automatically dealt by Flatcar.
Yeah, let me.
Thank you. It works also. Sorry. Yeah, thank you. It works also with with Docker. I just pass the GPUs. I just run an NVIDIA semi workload in this case. And I can do something like running Oyama. Who doesn't like LLMs these days, right? Okay, thank you. So I just pass a query to Oyama, which is entirely locally. So in this case, we're running DeepSeek on that particular machine, right? Asking about Flatcar. Unfortunately, I was not able to reproduce a situation in which at some point I asked DeepSeek about Flatcar, and the answer was like, oh, you're trying to run Linux on a train. That is very interesting, you know? Because a Flatcar in English is basically a flatbed train, which hosts containers. Unfortunately, that doesn't happen, so it's a very boring type of answer at this point. Okay, back to the slides. Now I will briefly talk about the opposite type of workloads. So instead of talking about the very big workloads, AI type of workloads, I'm talking about extremely small ones, where we think that Flatcar is a perfect fit. You know, in our domain, we moved from bare metal, so big physical servers, to virtualizing those physical servers, so you run full-fledged VMs. From VMs, we realized we don't have to actually run an entire operating system. We can containerize workloads. So we got to the container agent, then afterwards we got to the serverless when we realized that we just need to run only the workload we need to run without not only the operating system, but also whatever user space components we might need, right? The challenge we have when we run type of serverless components is that we need speed, meaning we need to spawn extremely fast our workload. So when you have a serverless function, you cannot wait the booting time required for a VM, right? And even containers can be a problem from that point of view. And then you have security. You need to sandbox all the workloads. And the best way to do that these days is using VM primitives, meaning that you want to use the CPU features for VMs, but without running a full VM. You want to limit the attack surface, you want to eliminate all the possible host and guest features and so on. And this is not a new idea. This is something that Google started with a project called CrossVM. From there, Amazon came out with Firecracker, which yielded up an open source project called RustVMM, whose team, by the way, is largely involved with people here in Bucharest. A great team, by the way. In parallel, we are cloud-based with CrowdStrike started a project called Insula, from Island, of course, and isolation. And that led to a project developed by Microsoft primarily called Hyperlight, which is what I'm going to demo right now. Hyperlight is meant to run basically a workload that you can define without an operating system, right? So you start a VM partition, and inside of that, you run only your workload, no operating system, nothing else, okay? It's a complex topic, so I will just run a demo to show how it works. Okay, that's me again. Thank you. Starting again another Flatcar, right? And then, sorry, one more time. And then I'm running a Docker container here. Okay, and it's done. So. As I mentioned, it's super fast. So this Docker container, if you look at the command line, passes through KVM, so we're running nested virtualization. It starts a very simple workload, which is simply sending a message on the console, right, inside of a virtual machine, okay? It took, on this completely non-optimized machine, 65 milliseconds to run, okay? And Flatcar can go down, so and Hyperlight can go down to microseconds, right? So this way, of course, it's a very simple demo, but this way you can also run WASM and other type of more complex workloads. Okay, I think we go back to the slides. Okay, passing back to Adi.
Thank you. So, takeaways. Flatcar is a simple, very easy to use operating system. It's easy to download, easy to consume, very easy to, let's say, extend, although it is immutable. So the composability part is it's strong with Flatcar. There are a lot of people that are starting to use Flatcar at the edge or on small devices. We have a lot of requests coming from, okay, add me that driver and that driver and that driver for mostly ARM stuff. That's why we also invested a little bit into the RISC-V architecture. It's ready for AI, is ready for bleeding edge software like Hyperlight. It's also generic enough to run all sorts of, let's say, legacy software. at the same time. So these are my our takeaways. Do we have more time?
We have just 1 minute left.
Okay.
Yeah, just 1 minute left.
Yeah.
Okay, so maybe we have some 1 minute for the questions.
Yeah, thank you. So thank you guys for the presentation, and if you have questions for Adrian and Alessandro.
If not, we will be around here, right? So it's.
Yeah, you will find out with them after this talk. And a lot of thanks, guys. This is very interesting from my point of view, and I see a lot of integrations with the Flatcar in the future.
Yeah.
So thank you.
Yeah. Thank you very much. Thank you, guys.